Hello gentlemen, today we'll be discussing about the combustion in the main engine. Well, in the previous times, the fuel pump used was of a different design as compared to the present fuel pumps. In reference to the combustion system, whatever be the load on the engine, whatever be the amount of fuel to be injected into the engine, or the onset of delivery of fuel into the engine was at a fixed time. So, as a result, the amount of load goes on increasing, the fuel to be delivered is also going on increasing. And as the time of fuel delivery and thus the injection of fuel to the cylinder was at a fixed time, the excessive amount for the higher loads, extra amount of fuel was high as compared to the low loads. Now the increasing amount of fuel was to be injected towards the later timings as the piston went on proceeding past the TDC. And it can be seen that this extra amount of the fuel kept on burning to such an extent that by the time the fuel finishes its combustion process, the position of piston reaches almost the time when the exhaust was opened. And due to that, as the finishing of the combustion is very near to the opening of exhaust valve, there was still a higher amount of pressure which now escaped through the exhaust gases, and thus the rather excessive amount of energy was lost through the exhaust gases, which was much higher than that required to turn the exhaust gas turbine and all the way up to the uptake. And it was now realized that the loss of excessive amount of energy could be retained for the useful work in the mechanical form for turning the propeller, which otherwise was lost with the exhaust gases. Or, in other words, the idea was to prevent the loss of energy to the exhaust gases, and that could be done by finishing the combustion well before it reaches the timing of exhaust gas valve to be opened, by using the lesser amount of fuel to be burnt after the TDC. And that, in simple words, means that the a part of the extra amount of fuel for the increasing loads, and now it is realized that as the load on the engine keeps on increasing, or in other words, as the amount of fuel was increasing for the increasing loads, a larger and larger amount of the fuel should be injected to the engine well in advance so that the finish of combustion would be at a time much earlier than the piston, which is the timing of the exhaust escape. And for that reason, the present type of the fuel pumps had to be designed, which is now possible to inject the fuel at the varying timings. As the amount of fuel to be injected is increasing for the increasing loads, a larger and larger amount of the fuel had to be shifted from the timing after the TDC to the time before the TDC, and increase in the advancement of fuel to be injected was necessary before it reaches the TDC. This way, it can be seen that instead of the fixed timing of the beginning of injection, now the necessity was to advance the timing of injection for the varying loads, and that was necessary to gentlemen, to get the maximum energy output. We have to ensure that the piston should be forced downwards the maximum pressure. That means we have to manipulate the situations such that the pressure can be increased. It is possible by either burning a large amount of fuel or burning the fuel at such a timing that it produces the maximum pressure. In the fuel pumps with the fixed delivery timing, it is seen that the amount of fuel before the TDC is fixed. That means the amount of pressure being generated at the TDC is fixed, and the difference in the pressure is only after the BDC, and that is generated when the piston recedes downwards, and there is a less chance that the pressure can be raised to achieve the maximum peak pressure, because even if the more amount of the fuel is injected after the TDC, at the same time the volume in which it is injected, it goes on expanding. So the combination of more amount of fuel being injected and the increasing volume results to almost a constant pressure without increasing the peak pressure. So there is not much of a considerable amount of the increase in work output in the mechanical form, and alternately the increase in pressure can be done by injecting a more amount of fuel before the piston reaches the TDC, and that combined with the rest of the incoming fuel near to the TDC will raise the peak pressure and thus the mean effective pressure, and therefore the energy output in mechanical form can be raised, which is of use to us to run the propeller. So to increase the amount of fuel before the piston reaches the TDC, we'll have to make sure that a portion of the fuel which is being injected after TDC has to be shifted over to the piston movement before TDC, before it reaches the TDC. That means the onset of delivery of the fuel has to be such that it has to be delivered at a time. That means the commencement of delivery of the fuel should be advanced. By doing that, it is seen that a greater amount of the fuel will have been injected, and thus a higher pressure would have been generated. And after that, almost near the TDC, the rest of the fuel will be delivered, and which will help us to increase the peak pressure, and that will increase the mean effective pressure. So that would result to the greater amount of energy in the mechanical form to run the propeller. By doing that, the finish of the injection of fuel will be earlier, and therefore the expansion of the gases will be finished earlier. By the time the piston reaches the exhaust valve opening, maximum amount of the energy will have been spent in the mechanical form, and the least amount of energy will be present with the exhaust gases, which is just enough and sufficient to run the turbocharger. So the advancement of fuel delivery will help us in two ways. One is to raise the peak pressure, and other one is to prevent the loss of excessive energy through the exhaust gases. So as the load on the engine goes on increasing, the amount of fuel also goes on increasing. Therefore, to finish off the expansion process well in advance, so that it does not come close to the exhaust valve opening time and does not allow the excessive energy to be lost through the exhaust gases, we'll again have to shift the portion of fuel being delivered after TDC to be delivered before TDC, so that now even a greater amount of peak pressure can be achieved, and thus the mean effective pressure will now be higher, and the work output in the mechanical form that we utilize to run the propeller will be more and more. So in general, it can be said that when the load increases, the advancement of fuel delivery has to be made more and more. But the advancement will have to be started at a particular timing, at a particular capacity of the engine. That is, at about 30% of the capacity of the engine, and it will go on being advanced right up to about 80% of the capacity of the engine, and thereafter it will again be reduced. Otherwise, a greater amount of the peak pressure will be produced, which might harm it physically and damage the engine parts. So this is the way how the advancement of the field delivery is made. We'll see with the animation in the diagram how it actually happens and the comparison between the normal fuel pump in the old models and the ones to the fuel pumps in the modern times or the VIT is implemented. So German, let's take this point of the barrel to be a reference point from which we are going to either lower down the position of the barrel or raise it upwards and see what happens. So when we lower down the barrel position, let's say we take it to this point. So it is clear that the time that the plunger will take to start delivering the fuel is now less than the one where the previous position of the barrel was there, because as the barrel has been lowered down, the distance between the upper edge of the helical cut of the plunger and the position of the port is now less. So the commencement of delivery will be faster than the timing of at the reference point. And on the other hand, if we raise up the barrel position, as the barrel position has been raised up, there is a more distance between the plunger and the position of ports. So the delivery timing will be greater than that for the barrel at the reference point. So it is clear that higher the position of the ports or the barrel, more is the time taken to start delivering. Or in other words, the fuel delivery has been retarded. And lesser the distance, lower the position of the barrel, earlier the fuel delivery. So we can see clearly that the position of the barrel either towards the upper side or towards the lower side controls the commencement of fuel being delivered. Or in other words, it is the position of barrel which controls the timing of fuel to be injected into the engine. So this is the meaning of variable injection timing, because it varies the injection timing of the fuel into engine. So this is what we saw as to what happens when the VIT arrangement is implemented. Obviously, it is of use and beneficial to use the VIT arrangement, because we saw that the peak pressure has been increased from P1 to P2, and the two, the duration for which the peak pressure lasted in the form of the sort of average pressure is now more, is obviously by a greater amount than what it was than the previous timing for which it was lasting. So this way the VAT has been helping the formation of a greater amount of work from the same amount of the fuel at different loads. This is all for this video. See you soon in the next video. Till then, do take good care of yourselves. Share this video among your friends so that they can also be benefited out of this. Do put your comments in the comment box and also give suggestions if you have any. See you soon in the next video. Till then, take care of yourselves. Bye bye.